Today's lesson is about one-step equations. What we're going to do today is solve equations. We're going to use some concepts to do that will be important for you as you go on through middle school math, particularly when you get to Algebra 1. And we're also going to use some things that we learned a couple weeks ago to help us implement the rules or the steps to solve equations. So if you remember your properties, we're going to use a couple properties in particular. So let's get started. Inverse operations is a key concept that you need to understand in order to solve one-step equations. So we're going to use those, and if you remember the properties unit, you might be able to answer this question: what are inverse operations? Well, if you remember, there's an inverse property of addition and an inverse property of multiplication. And basically what it said was that when you add opposites, the answer will be 0, and when you multiply reciprocals, the answer will be 1. So those properties are taught to you because they're important to understand when you solve equations. And you're going to use those properties to help you solve. So let's talk about how that works. Inverse operations undo each other. So here's what that means. If you add a number to something, the way you can undo that or take it away is by subtracting it. If you multiply a number by something, the way you can undo the multiplying is to divide by that same number. So you kind of end up where you started when you do that. If you add 5 to something and then subtract 5, you end up where you began. If you multiply something by 12 and then divide it by 12, you end up where you began. So that concept is going to be key for this. Okay? So adding and subtracting undo each other because they equal 0. That's what I just mentioned with the inverse property of addition. So here's some examples. -8 plus 8 equals 0, and 5 minus 5 equals 0. So that's positive 5 minus 5. Multiplying and dividing do the same thing, except they equal 1 instead of 0. So some examples of that: 8 divided by 8 equals 1, and 1/8 times 8 equals 1. So again, those are reciprocals. When you multiply them, they equal 1. That's undoing the operation. So equations must always be balanced. So here's how we're going to do this. We're going to use that idea of inverse operations, and we're going to think of equations as a scale. So if you look at the scale, there's going to be numbers on both sides. If you want that scale to be balanced, the numbers on both sides have to be the same. So for example, if I have 12 plus 5 on one side of the scale, in order to balance that scale on the other side, I have to have a quantity that has a value of 17. It can be anything that equals 17. I'm just going to put 7 plus 10 here because I know that equals 17. So right now my scales are balanced. I could replace that scale with an equal sign, and I would have an equation that was true. 12 plus 5 equals 7 plus 10. Why is that? Equations show that two quantities are equal. We are going to learn about inequalities, and inequalities are when two sides of a math problem are not equal, one greater or less than another. And then an expression doesn't even have an equal sign, if you remember, so it doesn't have two sides. But an equation is called an equation because both sides are the same. So if you add, subtract, multiply, or divide something to one side of an equation, you need to do the same thing to the other side in order to keep it balanced. So let's use our problem from before. If I have 12 plus 5 on one side, and I have 7 plus 10 on another side, they both equal 17. But let's say I decide to add 8 to the left. Now, if you add 17 plus 8, you get 25. If I want to get 25 on the other side, I have to also add 8 to that side to keep it balanced. It's kind of common sense. But you have to use this idea that is common sense, to solve equations, because if you don't, you're going to unbalance or make an equation that's not equal on both sides. Okay? So here's how we're going to do this. You're going to be working with problems that have variables. If you remember back from the expressions unit, a variable is a letter that represents a number. So here's an example. We have our scale in the middle, which again could be an equal sign. And it says 12, or x plus 12 equals 28. What you have to do is find the missing value for x. This is a fairly simple problem because you can probably do some quick math on the side and figure it out. But we're going to teach you a way to solve every equation or any equation so that when you have larger numbers that you can't just figure out in your head, you have a method to solve. So here's where the inverse operation comes in. To solve or balance the equation, you need to isolate. Isolate means to find the value or put the value by itself for the variable using inverse operations. So we're going to look at this problem and see what sign is here. Here we have an addition sign, so plus 12. Think about what inverse operations mean. What is the opposite of adding 12 to a number? Well, the opposite of adding 12 is subtracting, right? And if we want to do the exact opposite, we're not going to subtract 1 or 2 or 3 or 4. We're going to subtract 12. So we look at the plus sign, we do the opposite, we subtract 12. And since the equation has to stay balanced, just like I did earlier, if I subtract 12 from the left-hand side of the equation, I have to subtract 12 from the right-hand side of the equation also. When I do that, 12 minus 12 on the left-hand side is going to equal 0. So that just those numbers just go away. And the x just kind of comes down because I didn't do anything to the x. All I did was subtract away 12. And on the other side, if I subtract 12, 28 minus 12 is 16. You'll see that when we set equations up this way and do our inverse operations, the adding and subtracting is kind of already lined up for you, so you just need to, you could actually do your work right there if you had to borrow or carry or whatever. So the last thing I want to do here is check to make sure 16 is the correct answer. So I'm going to put 16 back into the problem where x is, and check to see if 16 plus 12 equals 28. Well, if I add 16 plus 12, I do get 28. And the very last line here shows that the problem is balanced. Both sides of the scale have a value of 28 when x equals 16. So that's the answer to the problem. X equals 16 is the answer. Here are some other examples. Okay, we're always going to do the inverse of what we see in the math problem. So we're going to start with the gray one and work our way over. Okay, the gray problem says 9x equals 72. Think about what sign goes in between a coefficient and a variable when there is not one there. That sign's multiplication. Next step, think about what the inverse or opposite of multiplying a number by 9 is. The opposite is dividing by 9. So we're going to write that like a fraction, divide by 9, and if I do that to one side of the equation, I have to do it to the other. So I'm going to divide by 9 on this side also. 9 divided by 9 is 1, so I'm left with 1x on the left-hand side, and on the right-hand side, I'm left with 72 divided by 9, which is 8. So 8 should be the value of x for that equation. Let's check our work. If I multiply 9 times 8, so I'm putting the variable, or replacing the variable of x with 8, 9 times 8 equals 72. And if you're good with your times tables, you know that 9 times 8 is 72, so we just balance the equation. We found the value for x that balances the equation. Okay? Let's try the middle one, the tan problem. Here we have x minus 18 equals 21. Think about what the opposite of subtracting 18 from something is, or the inverse. The inverse of that is adding 18. So I have to do that to both sides of the equation again in order to keep the equation balanced. And when I do that, negative 18 or minus 18 plus 18 is equal to 0, so they go away. And the x just comes down because I didn't do anything to the x. And over here, I'm going to do 21 plus 18 to get 39. I'll substitute or replace 39 with x in the equation to check my answer. And double check to make sure 39 minus 18 equals 21. It does. My equation is balanced, which means the value for x in this equation is 39. Okay? Last problem. It says x over 3 or x divided by 3 is equal to 8. Well, if you think about it, the opposite of dividing by 3 is multiplying by 3. So I'm going to multiply by 3 on both sides here. I'm showing you why this works also by putting a 1, if you see right here, next to the x. If you remember from the expressions unit, if a variable doesn't have a coefficient, you can put a 1 there. So I just wanted to show you that like the fraction here makes 1/3, and that reciprocal, or opposite of that, is 3 over 1. And when you multiply reciprocals, remember what I told you, that's the inverse property of multiplication, the answer is 1. So if we do all this work here, we're left with 1x, or just x. On the other side, 8 times 3 over 1, remember you can put a fraction bar and a 1 here to make that a fraction, and it's basically 8 over 1 times 3 over 1, which equals 24 over 1. And when I write that without the 1 underneath, it becomes 24. Okay, let's check our work. If I put 24 back in for x and do 24 divided by 3 equals 8, 24 divided by 3 does equal 8, so we balance the equation. So take a look at this work. When you get graded on anything in this unit, this is what your work needs to look like. You need to have the original problem written down. You need to have the inverse operation underneath it or next to it, depending on what kind of problem it is. That's where the red is. You have to have your answer circled so your teacher can find it easily. And then you also have to check your answer. You get graded on checking your work to make sure that you know the equation is balanced. The only way you know the equation is balanced is if you see something like this at the end of your check. Okay? If you see this, that means your equation is balanced and you have the correct answer. So actually do the work to check your answer. If you do, you will know ahead of time before you even turn in anything that's graded to your teacher whether it's right or wrong because you've done a check. So that is part of your work. When you're told to show your work, this is what it needs to look like. Okay? Let's move on. There's one other thing we have to go over with this. Oh, let me do this first. Let's do the practice problem. So on your practice sheet, hit pause, try these out, show your work the correct way, and then when you're done, you can unpause and see how you did. Okay? Here are your answers. So take a second, look at your work. If you tried number 1, the opposite of adding 11 is subtracting 11. So you can see my work here and my check. Number 2, the opposite of multiplying x by 5 is dividing it by 5. And again, we're writing that like a fraction because a fraction means division. There's our answer and the check. X divided by 6, the opposite of dividing by 6 is multiplying by 6. And you can see my reciprocals here that all go away and equal 1. So we have 1x left. And that balances out also. And then the last problem here, minus 5, the inverse or opposite of that is adding 5. So I did my adding, I checked my work, and it balanced. Okay? There's one more important concept to talk about with this. It's problems like this. You're going to get some equations problems that use your integer operations rules. And one of the integer operations rules deals with subtracting a negative number. So if you look at this to the way it is, and you try to figure out what the inverse operation of this is, it might be a little confusing for you. But if you remember the keep, change, change rule for changing subtracting problems into adding problems, it's going to help you make this way easier to figure out. So let's review that. If you see a problem that looks like this, you're going to keep, change, change. I know that sounds like keep, change, reciprocate, but remember keep, change, reciprocate went with dividing fractions. Keep, change, change is the rule you use for subtracting integers. So here's the rule. You keep the first number the same. You change the sign in the middle from subtracting to adding, and then you change the second number to its opposite. So when you do that, this math problem turns into x plus 5. So x plus, we'll put the signs in, x plus, and then positive 5. That's the keep, change, change rule. So now you should be able to easily figure out what to do with this problem because it says x plus 5 equals 16. If it says x plus 5, what you have to do is subtract 5 from both sides. So when you do that, the 5's go away because positive 5 minus 5 equals 0, and the x just falls down here. 16 minus 5 is equal to 11, and that should be our answer. So let's put that back in. If I go to check that problem, I put my 11 back into the variable right here, or in for the variable, I substitute, and 11 plus 5 is 16, and that does check out because 16 equals 16. Okay? And if it works here, if it works in this problem, and you do your math right, it will work in this problem also if you substitute. Because what you would do is put 11 in for x, and then you would do your keep, change, change to turn it into this one anyhow. So, important rule to remember, you will see problems like that. Okay? So let's try practice one. Try doing the keep, change, change rule, and then do whatever the inverse operation is to solve the problem, and don't forget to check your work. So hit pause, try this out, and then I'll show you the answer and all the work after you try it out. Okay, here's the answer. Keep, change, change turns the minus a negative number into a positive and plus sign, so plus positive, so x plus 12 equals 40. When you subtract 12 from both sides, you get x equals 28. And then when you substitute 28 back into the equation where x is, 28 plus 12 does equal 40, so you can see the equation is balanced. Okay? Just a couple other reminders. You may want to look at your integer operations rules as you go through this unit, because you're going to be subtracting and multiplying and dividing and adding with negative numbers. And just we'll refresh in class too to review those, but make sure you're familiar with those rules because it will come in handy. Okay? Feel free to rewatch the video if you need to. Use it for your homework and when you're studying, and I'll see you next time.